Welcome back. We are going to continue to solve that particular problem on moment. Now, we ended when we actually drew the force diagram. That is the horizontal force, 6 kilonewtons. This is breach diagonal. This is the weight of the force, which represents the weight of the breach, 8 kilonewtons. Not 8. Sorry about that. Now, the distance of the length of the breach is 2x because the weight acts exactly in the middle, and there will be x, which is half of the length, and another x, half of the length. So 2x is actually the total length of the breach. So we have to calculate the perpendicular distances of each of the forces from the pivot. Perpendicular distance of the line of action of this 8 kilonewtons is, I'll call it L. And the perpendicular distance of this horizontal force, which actually is applied to pull the breach over, I'll call it D. So we have to calculate it now. Now, this is the hypotenuse here, and this is alpha. So, generally, if we want to find this distance, if we want to find this distance, perpendicular distance from the pivot, then it will be opposite the angle, and the distance, which is the hypotenuse, is 2x. So 2x sine alpha is equals to D. Sorry, this has to be D here, because the perpendicular distance is the pivot. Right, that is the first perpendicular distance. Second perpendicular distance, which is L. Okay, that is the hypotenuse, which is x, and this is adjacent. So the L is adjacent to our alpha. So to say that x cos alpha is equals to L. So those are the two perpendicular distances. So this perpendicular distance is for the 8 kilonewton force, and this perpendicular distance is for the 6 kilonewton horizontal force. We can now apply our simple and fundamental law on moment. Force times the perpendicular distance. So let's apply it now. We have a small space here. I'll just make this is better here. So 6 times D will be our moment. So 6D, we'll call it moment 1. L times 8 will be the second moment. So 8L is equals to M2. So those are our two moments. Now we have to model this particular bridge to prove that if we are to raise the bridge, our tan alpha will be greater than 2/3. Okay, that will be the subject of our next video. Thank you.